Welcome back to the channel, and today it's going to be a kind of a different video. I'm not going to really do a lot of drafting in this video, more or less explaining, but when we do jump over to AutoCAD, I will show you some important concepts on scale factors and paper size and how they do relate together, right? So I promise you I'm probably not going to try to kill you with death by PowerPoint here in this video, and like I said, it is going to be a little different video. And please do leave me a comment below if you like this style of video as opposed to me doing some of the other ones where I'm trying to explain some of the more important concepts of AutoCAD as opposed to me just, giving you an example and doing some drafting. So this is, like I said, this is going to be one of those more teaching videos on the side of giving you more of a concept. All right, so let's go ahead and jump over and get started. Okay, so what we're going to be talking about today is going to be paper size and scale factor, and I know you can read that. And once again, when I usually give PowerPoint presentations, I'm not going to be a big reader of it, so I'm not going to sit here and just kind of read stuff that I know you should be able to read or understand, but I will try to point to and highlight some of the concepts and things of that nature that might be needed, right? All right, let's go ahead and get my pen ready here. Okay. All right, so when we're talking about paper sizes and scale factor and why they're important, and before we get started, this is relating to the drafting field as a whole, right? Some of the common sense things to tell you is that I can't represent a whole house on a sheet of paper. That's basically the main concept of this. So I have to have some way of being able to represent that on some kind of standard paper size, right? So the scale factor is what's going to tell someone or what you're going to actually scale your, and I don't want to give away it too much here, but you're not going to scale your object per se, although in reality it's going to look like your object is scaled down on the paper size, right? But it is just a way for you to be able to represent that on a piece of paper graphically, and then you should be able to measure to that, okay? So that's what all of this is going to be mainly about. And that's what it is telling us here in the first one, that the scale factor is used to basically represent a large item on a regular size piece of paper. All right. Now in the drafting field, we have two different standards. We have the ANSI standard, which is what we use in the United States. And we do have a ISO standard, which is going to be the international. And then there are some common paper sizes that we use on each one of those, right? So the most common sizes that we're going to see here in the US or in the ANSI standard is going to be just a regular letter size piece of paper. That is something that you see anytime you print something out of a printer or something of that nature, and that's going to be the most common size. That equates to being an A4 size in the ISO standard, right? They're not exactly the same dimensions word for word, but they're so close enough that they're kind of interchangeable. So if you see letter size, it's going to be this exact same as a A4. And as we get on through this presentation here, I will show you a little bit more of why it's done this way, right? Okay. All right, some more stuff that as it relates to the drafting field is that it's going to be a connection, right? So when we're doing this, the most important thing is that you may have to adjust your scale factor because it's really neat, especially in the drafting field, that you don't want to overcrowd your drawing. So right here is going to be your more important thing. You don't want that drawing to be crowded. You want everything as best as you can to be clearly legible, right? So you're going to have on that drawing, it's okay to go up another size if you have to. And what I'm talking about going up another size is that there are some standard sizes. And then there is something that you can do if you can't fit those standard sizes. And yeah, we'll discuss that as we go on here. Now, this is talking more or less in the in the ISO standard, is that you can see something that's super big, and in our standards, it may be 1/16 equals a foot. But if we're talking about something that we're trying to fit a large scale something on, we'll tend to use these bigger scales. But if it's something smaller or in the mechanical field or in the electrical field, we tend to get away with using some smaller scales. And you're going to see that once we get to scale factors. And then finally, in the drafting field, we'll typically have the title block. Now the title block does sit on the paper size. The paper size is not the title block. So I want you to think of more or less the paper size as the border as opposed to being the actual title block. The title block is what goes around it, and it's going to be that important, I guess, lower right hand corner, or it may be all the way down the side of it, but it has all of the information about the drawing. Now that is also going to be where you're going to see that not to scale or the actual scale factor or anything of that nature sitting there. And I already kind of gave you a little hint there. If you see this on a drawing, just remember that that means not to scale, right? That is, I wouldn't say is a bad thing, but it could be depending on what you're trying to do with the drawing. So if you see this on the drawing typically and something is missing, you're going to have to make a phone call, and I'll explain that a little bit later, right? All right, so once again, but on that title block, you're going to have whatever the scale is, and you're going to have whatever size that you're using, whatever paper size that you are using. Now, when this refers to AutoCAD, we're talking 2D AutoCAD right now. 3D AutoCAD has evolved. Although some of these same concepts can work for 3D AutoCAD, it will work if you're using any kind of viewports or things of that nature. But when I'm talking about usually, this is most likely going to be used when you're using 2D. But like I said, and I think I will be coming out with a video, or I may have a couple of videos where I actually demonstrate that you can use a three-dimensional object and you can use these viewports with it. And then you can also adjust the scales of those. But we're going to see that once we get to the AutoCAD example, right? But I want you to understand that anytime you're drafting in AutoCAD inside the model space, this is the important thing here, is that always, always, always draw it to the real world sizes. If you get, something out of this and you go to a job or something of that nature, don't tell them that I told you that, hey, he said don't draw it to the real size here in the model space. No. What I'm telling you is that you got to actually draw it. Now, there is an exception to this, and I will try to demonstrate that when we get to the example of it here in AutoCAD. But in model space, for the most part, and what this is actually telling us to use, this is assuming that we're going to be doing things in paper space and model space. But if you kind of worked before we did the paper space thing, you can also get away with doing this in model space, but that's where that rule is going to apply. If your drawing and your title block is going to be housed in model space, then you have to use an exception to this rule. But if you're going to be using paper space as means of doing your drawing, then everything that you create in model space will have to be the real size. That's going to be the representative of it, right? So now this is telling me now when I switch to the layout tab at the bottom, and that's where you usually see that gray piece of paper there, and typically we usually adjust that. If you've seen any of my three-dimensional AutoCAD videos, you can see that I actually usually adjust that to a B size. But that's what this is representing. So that's going to be your paper size, and that's where it's going to lay out when it comes to that. The viewports is going to determine what the scale factor of it is. And now once again, I'm talking about once we're in that layout, and this is talking about viewports, right? If we're doing everything in model space, then we have to adjust things a little bit differently. So we're not going to really do it this way. But once again, I promise you that once we get over to the AutoCAD stuff, I will show you how to, kind of, I don't want to say manipulate, but I just want to make sure that we clarify that there are kind of exceptions to this rule. All right. And then finally, when we plot, now when we plot, we can use this applies to both methods. So if you're doing everything in model space, or if you're doing model space or paper space way of doing it, this is gonna, it works exactly the same, right? Okay. So now we're at the point to where we're going to talk about some standard paper sizes. So if you're working in the industry and someone, especially here if we're using the ANSI standard, and they say, hey, I need that printed out as a D size, you're going to go print it out. And typically what you're going to do is going to print it out to a 36 by 24, right? Now, I know I give you all of these different sizes for it, right? And we have an A size, B size, C, D, and E. We have them for a mechanical and we have them for an architectural. Not to say that we don't use these, but the most common sizes that you're going to see is that anytime most people tell you to print out a B size, we're going to be using these two, right? So we're going to be using the 8.5 by 11, which is the dimensions for a regular piece of paper that comes out of your printer. So that's the A size. The B size is going to be the next one. And then once we get to the C size, we tend to cross over and start talking into the architectural scale, right? So this is when these come into play. So we kind of zigzag in between it. Now, if you're working for strictly an architectural company or some of that nature, you may actually stick to these sizes. Now, these can easily be calculated as well. And let me go ahead and clear my screen here. Is that it's really easy to calculate. The large number, so I got the 8.5 by 11. We're just going to carry that number down, right? And then we're going to double the smaller number, right? So that's all we're doing. We're going to double this number and we bring that down. And you just follow that format. So here is the smaller number. We're going to double it. And then we're going to carry over the bigger number. Double. Carry over the bigger number, right? And then we're just following that down. The exact same process works for when we're doing the architectural standard, right? Bigger number, carry it down. Smaller number, double. Bigger number, carry it down. Smaller number, we're going to double that, right? And so you can see that it's a real easy concept. But these are going to be the typical sizes because that's what most people say. They say, hey, I need that printed out as a D size. They're not going to tell you that, hey, go print me out that as a 36 by 24. Although some people will, but it's a lot easier just to give you and say, hey, go print that out as a D size and you're supposed to know. Now, when we come to the ISO standard, remember that things work a little bit in the reverse order. So at the beginning, I told you that an A4 is equivalent to this A size, and that's exactly what it's representing here. The A size is an A4, and the same process happens. The larger size, carry over, smaller size, double. We're going down, working the exact same concept. Bigger size, carry down, smaller size, double. Now, once we get to A1, the dimensions kind of get obscured, but we're talking millimeters here. So I want you to understand that. And if you know what a millimeter is, it's super duper small. So that's where there is a little bit of rounding error when you come to creating this, but they're so close that if you just went ahead and doubled this number, it will be the same. So if you notice that if I double this number here, this 420, it would give me actually 840. But what we're using or what we're seeing here, it's so close that it's an 841 is the actual dimensions for it, but we're still carrying over the bigger number, right? And the exact same thing here happens again, right? So if we do the multiplication on that, it's not quite double, but we're talking 1 millimeter bigger than what it is. And then we're going to carry over to the other one. So easy, super easy concept. What you're seeing here on the other side here is kind of a graphic representation of what's actually happened. So if this is an A size drawing, this is kind of what it looks like to be a B size, right? And then here's a C size. And then finally a D size, right? So you can see there are quite a difference between each one of the sizes. Determining which size pick this is going to be typically what is standard. So if you're working on doing a house plan or something of that nature, I can tell you right off the bat, you're going to be stuck here doing this usually in a D size. If you're working in the mechanical field and any of these other kind of fields, I wouldn't say civil, but you're typically going to be, kind of hovering around using things in the A and B size because their drawings are really going to not be that big. Not to say that they don't use a D size. I'm not going to say that. We do use C size sometimes. It works totally fine. But here are the representations of them. Now, you can see that without having a scale factor, if you had an object that was drawn at a certain distance, right? Let's say this object was maybe this long, right? You can go ahead and use an A size. That's not what I'm telling you here. You're going to have to scale the A size up and use a different scale factor, but you can get away with using that. There's absolutely nothing wrong with using whichever size. But most of the time, this is going to be picked on your standard practices, right? So there is not a, hey, if it don't work here, use a B size. It's typically standard practice like I was just mentioning to you. All right. So here are some common scales, and these are going to be the most typical ones that you're going to see. Now, I want you to kind of take note and look at some of these, and we're going to be talking about the scale factor column. This column here, where it says the paper scale factor, we're going to worry about that a little bit later. So once we jump over to AutoCAD, this category or this column we will discuss heavily once we get to that. And just to kind of give you a little preview of that, this deals with the viewports, right? All right, so these numbers here, they all can be calculated, and they're rather simple. And looks like I kind of got on here a little quickly. And they can be calculated rather easily, and I will show you how to do that, right? So for example, let's take one that should be super simple. Let's take a look at this one. And so this is 3/4 of a foot, right? So 3/4 of an inch equals a foot. All right. So the way that I'm going to calculate that, and I'm going to first, let's go ahead and write it down. And I will apologize. My handwriting will be a little bit bad here, but I will try to make do the best I can. So I have 3/4 of an inch is equal to 1 foot 0 inches, right? All right. So the way that we're going to calculate this, the first thing we always want to do is that we know that 1 foot is equal to 12 inches, right? We're going to put both of these in the same units. So we're going to go ahead and say, hey, and I know my handwriting will get a little bit bad as I keep writing. This is equal to 12. All right, so now I'm going to talk numerator versus denominator. So if you go back to your grade school days, the top number, numerator, bottom number, denominator. So I'm going to take my denominator and I'm going to multiply by this side. So that's going to give me 3 is equal to 48. And then the final thing I'm going to do is the number on the left side is I'm just going to divide it by this number, right? So if I divide both sides by 3, that gives me that this, and we don't have to show a 1 there, that just tells me that this scale factor here is going to be equal to 16. All right, so if I jump back to this page, this is equal to 16. Okay, real simple to do. You can do that with any of them. Let's just take the next one here, which is going to be super duper easy for us. So we have a 1 there for us. So if I take a look and go, hey, what is the 1/2 inches is equal to 1 foot? Okay, so I'm going to take the first thing, as I always do, is put them in the same units, right? That's got to be equal to 12. Multiply the denominator by that number over here, and it's just going to be simply 1 is equal to 24. Therefore, my scale factor is sitting at 24, right? And you see that here. So that way you can calculate any of these numbers. Super duper easy for us. If we're working here on the mechanical scale, it's actually super duper simple. Now I left these in fraction form, but I'll take this one for example, and I'll show you that why I left it in fraction form. So this is 3/8 equals an inch, right? So on this side, if I take a look at 3/8 equals 1. Okay. Same rules apply. These are automatically in the same units. It's 3/8 inches over here and it's 1 inch over here. So if I multiply the 8 times the 1, I simply get 3 equal to 8. And then I'm just going to divide both of these and I'll have 8/3, right? All right, so I can either put that in fraction form or decimal form for you. If we do it in a decimal form for you, we'll take the 3, and once again, like I said, my handwriting will get bad as I keep going on to here. And then I'll take it to an 8.0, right? I'll first do the division of it, right? So that's going to be 2. This will come down to be 6. This is 2, 0. I'll put a decimal point here. Next number will be a 6. And this is going to be 18, and you can see what's going to happen here, right? I'll come down and it's going to produce another 2. So this is actually going to go and be a number like let's see, let me get my pen right here. 2.66, and it just kind of repeats, right? It's a lot easier just to put that in a proper fraction, or I could leave it as an improper fraction. This is actually correct, as well as this is correct. And then lastly, if I did the other one, and I don't know if you remember how to do and make things into proper fractions, but I would divide this number, right? Once again, that equals to 2. This is going to give me my 6. And then whatever this comes down, we just take this number, this is my whole number, 2. We put the remainder, which is here, which is my 2, over the 3, right? So there's my proper fraction for it. And I know I'm going back into a little grade school stuff for you. So there's the improper fraction, there's the proper fraction, and then there's the decimal equivalent for you, right? So all of that is going to equal to here. But like I said, they're all the exact same number. Lastly here, if we're working, and I'm looking at the time here, this video is, we're going on about 20-something minutes. Here, the metric ones is a lot easier, and I do like working with the metric numbers a lot more. Let's go ahead and clear my screen here. Mainly because if I have a number that's sitting at 1.20, just treat this at these two colons as an equal sign, and it makes it a lot easier for you, right? So we back to the same thing that we did before. Remember that if I got a 1 on this side, that's my goal. Or if I divide this 1 by this 20, scale factor is simply 20. Okay? Super duper easy to do when we're dealing with the metric scale, and that's what you're seeing here. So therefore, all of these numbers here are doing the other thing. These numbers here at the bottom, and they also work the same for these as well, that if you see something that's sitting at a 2, colon, 1, all we're doing is just dividing both sides by 2, right? Because all I'm going to do is divide this side by 2 and divide this side by 2. It comes up with 1/2. Right, so we all know 1/2 is 0.5 if you want to think about it that way, but that's why we got this number here. Okay? Little homework assignment for you. And just make sure that you understand. Here's one that's, kind of always been confusing, but this one should be super simple for you to do, to be able to calculate what this scale factor is, which is 4, right? So all it is taking the 3, putting both of them by 12 divided by 3 should give you a scale factor of 4, right? So super duper easy concept to grasp. So why do I need to do all of this, right? That's the $1 million question. Why do I need to go ahead and figure out all of these scale factors and things of that nature? Because if you print this out on a drawing, and inside of your title block, and this is where I'm going to refer back to your title block, and I'm just going to draw a simple title block as if it was on this drawing, there's 2 pieces of information that is typically inside of that title block. The first one is going to be the paper size. So I say, hey, this drawing is drawing on a B size. And then the other thing that's going to be here is going to be the scale. And I tell you that, hey, this drawing is drawing at 1/4 equals a foot. Useful information. So now, these two pieces of information tells me that, hey, the drawing is made to a B size and it's drawing at this one. So if I print out this document on a B size, that means that I can go and find my scale, my drafting scale, that looks like this. So what I'm looking for is that a number on this scale that looks like this 1/2. And it's also going to tell you if it's an architectural scale or some of that nature. But it's going to have this important information on it. And from here, I can measure things, right? So I'm going to come back to here real quick. And if I drew something, and, excuse my drafting here, but if I drew something that looks like this, and then I put some dimensions down here, and I just said, hey, whatever that dimension is, and then I went across here, and I put a dimension going across here, And then I forgot to give you this dimension here. Well, if you have that scale, you can go and measure this line and it will calculate that distance for you, right? So it's a lot easier for you to be able to look on here, but remember that you have to have these two criteria. You have to have the drawing printed out to this size, and you have to know the scale factor. Now, this is what I was telling you in the beginning. If in this title block here, and it has this dreaded word of NTS, now you might have to make a phone call, right? Because this just tells me that, hey, you did not use, or whoever drew this did not use a typical drafting scale. And that's all of these are. These are drafting scales that they have actually developed a scale for. That's why it's not to a scale, right? So it's not to one of these scales. So you have to either call somebody and have them open up the AutoCAD drawing and get it, or there are some other constructive ways of producing that, right? But remember, the most important rule here in order for you to be able to use this is for that reason. Now, I know it's becoming kind of one of the things of the past, because I know we print out drawings no matter what the size of them is, and most companies may not even put this on their drawings anymore. But if you did have this information, you can use these drafting scales. Now, if you're one of these super old drafters like myself here, and I'm referring back to when I did any kind of board drafting, is that we actually drew to these. So we would actually go, okay, what do we want our drawing to be? We would actually get the scale first, and then we would actually draw out the lines according to what we did, right? So it works both ways. So if you did any kind of board drafting, you would actually start with the scale first. But in the computer-aided drafting world, we can make whatever scale we want, and then we can go ahead and adjust it to it. Up here at the top, you have some kind of different scales that you might see or what you might buy from Amazon, but this is typically why these scale factors are so important. Now, we're going to get ready to switch over here to AutoCAD, and I'm going to show you an example of how it does when we're looking at the 2D portion of it. And we're going to look at it, well, I shouldn't say 2D, in the model space world, and then we're going to also look at it here in the paper space world. All right, so now let's jump over to AutoCAD and then kind of, work with doing that kind of stuff. Okay, so now we're in AutoCAD, and what I'm going to do is I'm just going to, let's bring in an example of something. Now, I don't know if you've ever saw me do this before, but I'm just going to type in DC. That stands for the Design Center. Once I open up the Design Center, I'm just going to go ahead and click on it, and I know yours is probably going to be taking a look like this, but I want you to click on the Folders tab up here at the top, and then I want you to navigate to this location, and you can see it here at the bottom. It says Program, Autodesk C, Sample. I'm using a English US version, and then underneath the Design Center, I'm going to come down to where I see Landscape, and then if you click on Blocks, that's what this is navigating to. And what we're going to do is I'm just going to bring in this car here. So instead of actually drafting something, I'm going to bring in a car. Let's go ahead and drop that here. And then I'll close my Design Center. Okay. Now you see that we have a perfectly drawn car, right? So I'm going to go ahead and make a paper size of this one, right? So I'm going to determine that, hey, let's go ahead and draft this thing to a B size. Now, I want you to also keep one thing in mind, is that we are dealing with doing everything in model space, and then we'll talk about paper space here after I explain to you what happens here in model space. But here in paper space, I'm going to go ahead and, this is where you would probably insert in your title block, but I don't have a title block to really share with you, so I'm just going to go ahead and draw in whatever the paper size is. And we're going to be using a B-size paper size, right? So the way that I'm going to do this is just simply use a rectangle. The lower left corner of your paper size should always be at 0, 0, enter, and then the upper right is going to be 17, 11. So remember, I'm using a B size. So this is now the size of my title block, right? Or, sorry, my paper. We see that this card does not actually fit on this paper size. Now, what I like to do, and what your title blocks would typically come in, is as a block. So I'm going to go ahead and make this a block because I can use those extra additive benefits to it. So while I have this rectangle selected, I'm just going to hit the Create button. Once this comes up, I'm just going to call it Let's just call it TB. I know it's not a title block, but just for sake here, I'm just going to call it TB. It's already selected. It's going to convert. I'm just going to hit the OK button. And now I have a title block. The reason I did this is now when I select this, and let's go ahead and do a right click and go to my properties, is that in my scale X, my scale Y, and my scale Z, in my case, I have them all set and turned on when I created a block, but all of these are going to scale uniformly. This is going to be my actual scale factor, right? So depending on which one of these scales that I'm going to use, and I'm going to kind of pull this in back and forth for you, is that I can figure out and determine, I can kind of play with this. This can be trial and error, or there is some kind of logic behind this, right? So I know that the overall length of my car is a certain number, and I can multiply that times the length of my paper, and then that'll give me a rough estimate of where I need to be. If you don't want to do that, by all means, you can sit here and you can play with numbers and you can go like, okay, let's see if 12 will work. And I can go ahead and type in 12. Let's zoom out and go, hey, that actually fits, right? And then I'll go ahead and move my car to the inside. Oh, it's a block. Huh? That's the good thing about it being a block. Yeah, I can just go ahead and move my car on the inside, right? And that works totally fine. And it's perfect. Everything is happy, and everything would fit. So in my side of my title block, what I would list to it is that I have a scale factor set to 12. So this is the important part of it, is that now I will go here, and then I will go find what scale factor is set to 12, and then these numbers here is what you're going to see inside of your title block, right? Okay, so that's going to be my scale factor for this one. Here's that example that I told you. So if you're using everything strictly in model space, and I want to make a detail of something. So for example, I have this car sitting here, and let's go ahead and move it down a little bit. And maybe I want to take a look at this tire here, and I'd say, hey, I want to put a detail. Maybe this tire got a cool little rim on it, and let's make some kind of rim on here. I'm just going to draw a line going straight up to here. And let's do a array. Select this line here and make it polar. And I'll click this point here. Okay. There's my cool little rim today. All right. So we have this nice cool little rim, and I want to make a detail showing that out. So now keep in mind that everything that I dimension here is going to be super small. It'll be super tight. And I say, hey, I want to detail this tire out here. So the first thing I would do here is I'm going to copy this. And let's copy this going up here. All right. Then I would explode this. So I'm just going to type in X and explode it. Let's go ahead and get rid of everything here. And now this is not going to be a full detail of it. And let's do one more detail of it. Well, let's see. Nah, let's go ahead and get rid of it. I was going to try to save a little bit of this just to kind of leave on the drawing. But anyway, this is the tire that I want to, kind of dimension and do some stuff to it. And you can see that this lies the same problem. Now, once again, I want to caution you that this is strictly that everything is in paper space, right? So I'm going to scale this thing up. So if I go to scale, and I click here, and let's say I want to make this thing, let's make it twice as big just to keep the numbers. So now I'm able to deal with this on a much bigger scale, right? So I can put my dimensions on here. Here's a detailed dimension of this. So that's where that exception lies at, is that you can make an exception when you're doing the real world aspects of it, only if everything is in paper size. But what I'm telling you is that keep this at the same distance. This is my main drawing. Always keep your main drawing at the paper scale. This detail view can be at a different scale, right? Now, some little homework for you is that you see me scale this thing up twice. I wonder if you can actually figure out what the scale factor of it is. Go ahead and leave me that in the comment down below. That's kind of one of those interesting things that if I have my drawing set up to this one and my scale factor is still sitting at 12, so it's 1/2 equals a foot, what will be my scale factor? Okay, so this works perfectly fine that if you're using this and just drawing dimensions, and I'm not going to put any dimensions on this or do any of the other stuff. I know in my other videos I go through that a lot, but if I'm strictly using everything in model space, remember, and I hate to sound like a broken record, is that try to keep your main view here. This view, this scale is going to be set to that 1 inch equals a foot. Okay, anything else that I use off of that, this dimensional one, I'm going to adjust the scale on this. Now I have to put the scale down below this one and tell somebody that this has been scaled up. You know, you can put not to scale under this as well, although it's not accurately correct. But if you couldn't figure out what that scale factor was and you actually put not to scale underneath that, technically you're not incorrect. But it's nice to figure out what that scale is. All right. So this takes care of everything that you have to deal with here in model space, right? So that's the exception to the rule. Now, if I'm going into paper space now, and I'm just going to erase all of this stuff. Remember that paper space works a lot differently, right? When we click on this layout tab here at the bottom, we usually get this happening. And we have a viewport that's going around here. First, I'm going to adjust my paper size. Remember that we adjust the paper size by going to the layout scale, do a right click on it, page setup manager, come into here, go to modify. I always set this to DWG to PDF because it has all of the paper sizes on it. I'll go here and select ANSI full bleed. And where's my ANSI full bleed? B size, 17 by 11. And we don't have to worry about any of this other stuff here, but I will set this to extents. Or maybe I should actually put a title block, because now that I'm thinking about it, it might go a little haywire. So you might see me come back and adjust this here in a second. Let's go ahead and hit center plot. And leave it set to 1 to 1. Let's go ahead and hit OK and then close. Okay. So it did actually adjust the paper to the right size. Okay. So now we have this. Here's the beauty of using paper space versus doing things in model space, is that once I double click on the inside of this, I can simply use the fly up here and say, hey, go ahead and adjust that for me to that scale. And let me go ahead and kind of widen out my viewport here. And you can see that now that car that we have created is the exact same size of that car that we had. Or it might be a little bit bigger if this is a B size. Let me make sure that this is a B size drawing here before I tell you anything differently. Let's go ahead and put a rectangle. 0, 0, enter 17, 11. Okay, and let's go ahead and move this over into here. Okay, and then what I'm going to do to just readjust this, I'll do a right click on here, go back to my page setup manager, the modify button, and then hit OK. It should adjust. There we go. Okay, so now you see that the car was the exact same size as what it was when I created it inside of the model space. Let's double click on the inside of here, and then I'm going to go ahead and turn off the grid in here. Let's do that. Okay, let's double click back out here. Now, if I wanted to make that detail of this rim like I did before, let's go ahead and move our drawing down a little bit. And the other thing about this viewport is, let's go ahead and make it a little bit tighter to my actual drawing here. Okay. And I'm just going to move this down. Okay. Now I'm going to actually cut a viewport, and I want to take a detail of that tire. So once again, the beauty of using paper space concept is that, let's go to the layout tab here, and then let's go ahead and get our special little scissors out here to cut through and take a look at the model space. So I'm just going to use a rectangle. And then I'm just going to make a rectangle right here. Looks good. Let's zoom into this one. Let's double click. Now I'm going to go in and I'm just going to focus right in on this tire. Right? So I scaled this thing up 2 times. My scale factor was 12. I'm going to kind of give you a little hint that if I scale this thing up twice as much, right? Let's look at what the scale factor will be. I can come down here at the bottom and I can play with this a little bit. And I can say, hey, I scaled this thing up 12 times. It's at a scale factor of 12. Let's see what the 1/2 one will do. And that's at 8. And now I actually know what the scale factor of this one is, right? The scale factor is sitting to this number. This actually has a scale factor of 8. If you're wanting to do the math of this one, and I'll kind of give you the little hint of it, is that the scale factor of our other one happens to be 6. If you scale it up 2 times, equivalent to dividing it by 2. I know that's a little bit confusing. I multiplied it up 2 times, but I have to divide that number 2 by whatever the scale factor is. So the scale factor of that is 6. If you go back and reference to my document there's not a scale factor of 6 on it, right? That is a not to scale acquaintance here. But how can I get this to scale to 6? So if I double click on the inside of this, is there any way that I can do that? Well, short answer for that is yes. So if I go to scale, I'm just going to type in SC. I'm sorry, not scale. I'm going to type in zoom. Z, enter. And now what I have here is I have to enter the scale factor, and then I have an X or I have an XP. Remember that I told you that we were going to talk about that last column on here. Once we get to paper space, that's what this last column deals with. It deals with the XP value of it. So if I want this to scale to a 6, I'm going to type in 6 XP. And when I hit enter, that's going to zoom in. Oh, did I go all the way in? Let's see, maybe I went in too far. Oh, is it 1 divided by 6? I kind of lost myself. Yeah, I'm sorry, I did. I actually went backwards. I told you one thing and I did another thing, right? Remember that the scale factor was set to 12. I set the scale factor to 6, right? But remember, I'm doing a zoom to the paper space, so it's actually 1/6. So it zoomed in super duper close. Let's go back to here. Let's go to zoom, scale, 1 divided by 6 XP. And now this is the actual scale of what I did to my tire in that detail before, right? So if I was to double the size of this, that is the scale factor. So to answer my question that I gave you before, actually was a trick question, right? It was not one of these scale factors. It happens to be a not to scale because it does have a scale factor of 6. All right. Now, the other neat thing is what you're going to see down here is that if I come here and click, it actually gives me that scale factor, what it is down here, right? So that's another one of those neat little things here. But that should be kind of everything that you need to know, that if you're dealing with scale factors versus paper sizes and things of that nature, just to kind of sum it up for you, that all of this stuff is kind of linked together here, especially when you're doing any kind of drafting portion, is because you need to know what size your scale is in order to make it fit onto the title block. If you don't want to, or I shouldn't say if you don't want to, if you can't calculate it, don't be afraid to use the not to scale if it's something special. Don't put a weird scale on your drawing, right? So don't put something, super crazy on your drawing and say, hey, yeah, this is a weird scale factor of like, I want to say like 5 and, although you could do this, 5:30 seconds is equal to a foot. It's probably a lot easier to make it not to scale because they don't make a actual scale to that. So that's kind of to sum it up. All right. So hopefully you got something out of this video. I didn't expect it to be this long, kind of explaining these concepts. But hopefully you did, kind of catch something out of this. And if I missed explaining a concept, please let me know and I'll try to come out with a shorter video on this one. And I know for some of you, the more important things was just trying to figure out how to calculate a scale factor. But I had to kind of blend it all in together to give you the whole grand aspect of how this stuff actually ties in together. So, and once again, if you like these type of videos, go ahead and let me know if you want to learn more of the I guess, the nuances and the concepts behind drafting and AutoCAD, as opposed to me just giving you examples and letting it fly, right? So hopefully you enjoyed this lecture. Please go ahead and hit the subscribe, comment, and let me know if this is something that you're actually interested in, all right? So go ahead and enjoy, and thank you for watching this.